Hello, in this video, we will present a case study on the nine-tail problem. The nine-tail problem is to place 9 coins in a 3x3 matrix like this, and this is the head and this is the tail. You can flip a head. When you flip the head, all its adjacent cells are also flipped. So if you flip this H right here, so this H and this T will be flipped. This T will be flipped to H, and this will be flipped to T. So you can only flip the head. So let's flip it now. I'm going to flip this one right here. See what happens. Flip this, so it becomes this right here. Now, the problem is to find the minimum number of flips so that everything is flipped to tail. So now, if we flip this H, so everything is to the tail. So that is the solution. We're going to write a program to find a solution for any input. So if you get a random state, so how you find a solution. And so this is just keep trying and keep trying. So this is very hard. So here, H, let's flip this to H and T, so you flip this to T and all this neveling to H now. So it's difficult to task. We're going to write a program to find the solution. We're going to use the graph to model this problem. So what we are going to do is to look at all the possible states. So you have this all this 9 coins, and 0 means it's head and 1 means it's tail. So you put all this combination, this total is 512 states. So we're gonna label all this as 0, 1, 2, 3, all the way to the last one is 511. Now please note that this is 9 zeros, and this is all this is 0 except the last one is 1, so this is 2. So you can now flatten this into 9 bits. So into 9 bits, so that's simpler way to represent the 9 coins problem in the program. So you have this is the numbers. It's actually here is this number is for 0, and this is for 1, this is for 2, this is for 3, and this is for 511. So when you flip right here, so this is 56, and from here you can flip 1. Like here, this one here, if you flip this, the first one here, 0 to 1, so this becomes 0, this becomes 1, so that's right here, this one, it becomes this number. If you flip this in the middle one here, this is the first row and the middle one, so it becomes 1, 1, 0, like this. And flip this 0, so it becomes this one right here. It's 1, and this is 1, and this is 0. So we're going to create a graph with 512 vertices. And there's an edge between the 2 vertices if you can flip this right here. So this one, and to become this. So there's 2 vertices, there's edge from this vertex to this vertex. Now, eventually, you're going to flip everything to 1. So this is right here, something somewhere here with 511. We need to find the shortest path from this root, it's 511, to any of these vertices. So we built this 9-tail model. This is a tree. So this tree here is it's a breadth first search tree. So we create all this vertices and the edges and create the graph. So we get this model, this tree. From the tree, we can get the shortest path. From any vertex, you can get the shortest path from 511 to this vertex and get the node. So this is the, given the index, you can get the node consisting of 9 characters, H and T. So this is like here, it's if you have this is 511, you have all T's, 9 T's, you have 0 is 9H. So if this is 2, you have this is H, 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 T, H. So that is this. Get node and get index. So giving a node, and so what is the index for this? Print the node, print the edge, get the edge, get all the edges. So this is get flip the nodes and flip a cell. So this is the program for 9-tail. So we're gonna create the graph. So create the graph. So here is 9-tail, and you create all the edges and creating the graph from all these edges, and the nodes are from 0 to 511. And now with this graph, so you can get the breadth first search, starting from the last one is 511. So this is the program to get the 9-tail model. Now we can write this 9-tail program. So we're going to prompt the user to enter the input like this. It is, so you have this is a matrix 3 by 3, but when you enter the input, you enter this way, enter 1 string. So this is the first row, H. The second row is 3 T's, and the last row is 3 H. So we have this input. This is the input we're getting. That's the input here for this initial node. This is the initial node. And from the initial node, we're going to create the model. So this is the model here. Let's create the model here now. This is the create model. It's the one we have here, the model here. This is the model here. Here's the constructor. So this is 9-tail. So this is the model. So this is 9-tail model. Let's call this as model. And now we can get the shortest path. Here is model.getIndex. So that's initial node. So the corresponding index. And using this model.getShortest path from the root, that's 511, to this index. And then now you can print this node. You get this path. So that is the path from the root to this index. So you can print everything in the path. So here's the model.getNode, get every node here, so print it out. So that is here, the printout. So this is the initial, and now you flip this, the last one here, to T. So the neighboring, and this becoming T, and this becoming H. And now, so you flip on this, so everything becomes T. That is all for this case study on the 9-tail problem. See you on the next video.